Hey everyone, and welcome to another deep dive. Today we are going to tackle something that's both mysterious and powerful. The solar wind. We've got some excerpts from a NASA article all about a brand new instrument. It's called CODEX, and it's heading to the International Space Station to unlock some serious secrets about this supercharged breeze blowing from the sun.
What's really cool is that CODEX is going to help us answer questions about the solar wind that have puzzled scientists for decades, like why is it so much hotter than the sun's surface? And what gives it such incredible speed?
Okay, yeah, those are some pretty big questions. So, to start off, what exactly is CODEX and what makes it so special?
Well, CODEX stands for Coronal Diagnostic Experiment, and it's a next-generation coronagraph.
A coronagraph.
Yeah, so imagine trying to study a firefly hovering right in front of a spotlight. That's basically what it's like trying to observe the sun's corona, that faint outer atmosphere with the sun's blinding light in the way.
I get it. So it's like trying to hear a whisper in a rock concert. Exactly. A coronagraph acts like a cosmic hand, blocking out the sun's glare so we can focus on the faint corona. CODEX is actually set to launch today, November 4th, 2024, aboard a SpaceX resupply mission to the International Space Station.
Wow, today. So it's happening right now as we speak.
And get this, it's going to give us a constant real-time view of the solar wind as it evolves from the corona outwards.
Whoa, a never-ending eclipse show.
Pretty much.
Sign me up. But tell me, we've known about the solar wind for a while now, right? So what are the big mysteries that CODEX is hoping to uncover?
Well, one of the biggest head-scratchers is the temperature. The sun's surface is about 10,000 degrees Fahrenheit.
Yeah, that's already pretty hot.
Right. But the solar wind, which comes from the corona, can reach millions of degrees.
Wait, millions of degrees? That's like stepping out of a sauna and into a volcano? How is that even possible?
That's one of the big questions CODEX will hopefully help us answer. It has all sorts of seriously cool tech on board, including special filters that can measure the temperature, speed, and density of the solar wind. And not just measure it, but do it with incredible precision.
So CODEX is going to give us a full profile of the solar wind, its speed, temperature, and even what it's made of.
You got it.
That's pretty amazing. I mean, I love how much testing has gone into this. It's not just some idea they cooked up overnight, right?
Absolutely not. CODEX actually has a long history, going all the way back to ground-based observations during actual solar eclipses. They even sent a prototype up on a high-altitude balloon back in 2019 to test out some of the key technologies.
So they've really been putting CODEX through its paces. I'm sensing a but coming here, though.
Yeah, well, while those tests were super important, they could only provide a glimpse of what CODEX can really do. To really get the long-term continuous observations we need to crack the code of the solar wind, they needed to put it in space.
Ah, that makes sense. And that's where the ISS comes in, orbiting high above Earth's atmosphere and giving CODEX a clear view of the sun. And the timing of this launch is pretty strategic, too. It's happening during solar maximum, a period of intense solar activity.
Right, that's no coincidence. During solar maximum, the sun is basically putting on a cosmic fireworks show, with more sunspots, solar flares, and coronal mass ejections.
Whoa.
All that activity means there will be a wider variety of solar wind phenomena for CODEX to study.
So it's like sending a detective to a bustling city during rush hour, more action, more clues to uncover. Speaking of clues, tell me about these different types of solar wind that CODEX will be studying.
Okay, so there are two main flavors of solar wind. One is what we call the fast solar wind, which is constantly streaming out from coronal holes.
Coronal holes.
Yeah, they're these cooler, less dense regions in the sun's corona. Think of them like giant vents just spewing out high-speed particles.
Okay, so that's the speed demon of the solar wind.
Exactly.
What about the other type? What makes it different?
The other type is the slow solar wind, and it originates from these magnificent structures called coronal loops. Imagine giant, fiery arches reaching high above the sun's surface.
I'm picturing it.
These loops are filled with superheated plasma, and sometimes they snap and release bursts of this plasma out into space, and that creates this slower, denser wind.
Wow, those coronal loops sound amazing. Like something out of a sci-fi movie. I can't believe we're actually going to see them releasing bursts of plasma in real time.
It's going to be incredible. And what's even more exciting is that CODEX will be working with other missions like Solar Orbiter and the Parker Solar Probe.
It's like having a whole team of space detectives working together.
Exactly. And each mission brings something unique to the table. While Parker Solar Probe is getting up close and personal with the sun, taking measurements from within the solar wind itself, CODEX's position closer to the sun will give us a different perspective on how the wind evolves as it travels outwards.
So, By combining the data from these different missions, we can create a much more complete picture of the solar wind's journey from its origins in the sun's atmosphere all the way to its effects here on Earth.
You got it.
And that brings us to one of the most important reasons for studying the solar wind in the first place, its impact on our planet.
Right, because this isn't just about satisfying our space curiosity. There are real-world implications here.
Okay, I was just thinking that. So how does the solar wind actually affect us here on Earth?
Well, the solar wind isn't just blowing harmlessly through space. It carries with it a constant stream of charged particles that can interact with Earth's magnetic field, which causes all sorts of interesting effects. Sometimes these interactions can be quite beautiful, like the auroras we see at the poles.
Oh, the northern lights. Those are definitely on my bucket list.
But I'm guessing you're thinking these interactions aren't always so pretty.
Yeah, that's what I was wondering.
Unfortunately, no. Strong bursts of solar wind, especially those associated with coronal mass ejections, can trigger what we call space weather events. These events can disrupt satellite communications, GPS navigation, and even cause power outages here on Earth.
Wow, that's scary. I hadn't realized the solar wind could have such a direct impact on our lives.
It's a good reminder that we're not just passive observers of the cosmos. What happens on the sun can have very real consequences for us here on Earth.
So understanding the solar wind isn't just about unlocking scientific mysteries, it's also about protecting our technology and infrastructure from potential harm.
Exactly.
All right, I'm officially hooked.
Glad to hear it.
CODEX is on its way to the ISS, ready to start unraveling the mysteries of the solar wind. And I'm curious, how exactly does it work? What kind of data is it going to be collecting? Tell me more.
Well, that's where things get even more interesting, but I think we should save that for part 2.
You're killing me. All right, fine. We'll have to wait to hear more about how CODEX works its magic. But for now, we'll leave our listeners with that cliffhanger. Be sure to join us for part 2 of our deep dive into the world of the solar wind, where we'll delve into the inner workings of this incredible instrument. Until then, keep looking up.
Okay, so we're back, and I am ready to hear all about how CODEX actually works. You mentioned it uses light to unlock the secrets of the solar wind.
Yeah, it's kind of like a detective dusting for fingerprints, but instead of fingerprints, CODEX is looking for clues in the light coming from the corona. It uses a technique called spectroscopy.
Spectroscopy.
Basically, it splits the light from the corona into different wavelengths, kind of like a prism, creating a rainbow,
Oh, right.
But instead of colors, CODEX is looking at those different wavelengths of light coming from the solar wind.
Okay, and what can that tell us?
It's like reading a secret code embedded in the light. Each element in the solar wind emits light at very specific wavelengths. It creates the unique fingerprint, you could say. So each element has its own light signature. That's really cool.
Yeah, and by analyzing these wavelengths, CODEX can determine not only the speed and temperature of the solar wind, but also what it's made of, elements like hydrogen, helium, even heavier ions.
Wow, it's amazing how much information is hidden within light.
I know, right?
It's like CODEX is a high-tech translator decoding the language of the solar wind.
I like that. A high-tech translator.
And remember those coronal loops we were talking about? The ones that launch those blobs of plasma into space?
Yes.
Well, CODEX is specifically designed to measure how hot those blobs are.
That's right.
And you said that's a key piece of information for solving another big solar mystery.
It all comes back to that mind-boggling question. How can the corona be millions of degrees hotter than the sun's surface?
Right, that's what we were talking about before the break. It's like finding a scorching hot oven mitt lying miles away from a fireplace. It just doesn't make sense.
Exactly. It defies our everyday experience with heat. And to make it even more puzzling, the exact mechanism behind coronal heating is still a big debate among scientists.
A scientific showdown. I love it. Okay, so remind me again, what are the main contenders in this cosmic heat battle?
Okay, so one theory is all about what are called nanoflares. Think of them like mini solar flares, constantly erupting all over the corona. Individually, they're tiny, but together they release a ton of energy, enough to potentially heat the corona to those extreme temperatures.
So it's like a billion tiny campfires all over the sun, creating this intense heat. That's wild.
Yeah, it is.
What about the other contender? What's their mechanism?
The other theory involves something called Alphen waves. Imagine ripples on a pond, but instead of water, it's magnetic energy traveling from the sun's interior out to the corona. And these waves can carry a lot of energy. When they reach the corona, they deposit that energy, causing it to heat up.
Okay, so we've got these explosive nanoflares versus these, like, surfing waves of energy.
I like that, surfing waves of energy.
Okay, but how can CODEX tell us which one is right? How can it help us figure out which of these is actually responsible for coronal heating?
By carefully analyzing the temperature and behavior of those plasma blobs. If CODEX sees evidence of sudden, localized heating events, that would point toward nanoflares being the main culprit. It'd be like those blobs are getting hit by a series of tiny but powerful explosions.
Oh, okay.
But if it observes more gradual heating associated with wave-like patterns,
Yeah.
then Alphen waves might be the driving force.
So CODEX is like a detective looking for clues, but instead of footprints or fingerprints, it's looking for heat signatures.
Yeah, exactly.
This is getting intense. I'm on the edge of my seat here, waiting to see what CODEX reveals. And you know what else is cool?
What's that?
All of the data that CODEX collects will be made public.
That's right.
Meaning scientists from all over the world can access it, analyze it, and work together to unlock these solar secrets.
Yeah, it's really going to be a global effort.
That's what I love about space exploration. It brings people together from all over the world. Speaking of global efforts, CODEX itself is a collaboration, right?
It is. It's actually a joint effort between NASA's Goddard Space Flight Center and the Korea Astronomy and Space Science Institute, with some help from Italy's National Institute for Astrophysics, too.
So it's a truly international project.
Definitely.
It's really amazing to see how different countries can come together to push the boundaries of our knowledge.
Yeah, it's really inspiring.
Okay, so CODEX is up there gathering data, and scientists all over the world are eagerly waiting to analyze it. What are we hoping to see? What kind of breakthroughs are we anticipating?
Well, one of the most exciting possibilities is that we'll finally understand where those different flavors of solar wind come from.
The fast and the slow.
Exactly. We know the fast wind comes from those coronal holes, but the origin of the slow wind is still a bit of a mystery.
So it's back to those coronal loops, right? I'm guessing those bursts of plasma they release are somehow connected to the slow solar wind?
That's the leading hypothesis. But there's still a lot we don't know about how those loops erupt and how their plasma contributes to the slow wind.
So could CODEX be the key to finally cracking this slow wind puzzle?
It very well could be. By studying the composition and properties of the solar wind coming from different regions of the sun, CODEX could help us pinpoint exactly where the slow wind originates and what mechanisms are driving its formation.
It's like tracing the ingredients back to the source,
Yeah.
following those breadcrumbs to see where they lead. But why is knowing the origin of the slow wind so important? I mean, is it just a scientific curiosity, or are there practical implications here too?
Well, remember how we talked about the solar wind's impact on Earth? Those space weather events that can disrupt our technology?
Oh, right. Yeah.
Well, it turns out that it's the slow solar wind that's mainly responsible for those events.
Wait, really? The slow wind is the one causing all the trouble. I would have thought the fast wind, with all its speed and power, would be the bigger problem.
It is a little counterintuitive, but it's the slow wind that tends to carry these giant clouds of magnetized plasma called coronal mass ejections, or CMEs for short.
CMEs.
And when those CMEs hit Earth's magnetic field, they can trigger geomagnetic storms that can lead to those disruptive effects.
Oh, wow. So understanding the slow wind, its origins and behavior, is actually really important for protecting our technology here on Earth.
Exactly. It's about protecting our satellites, our communication networks, even our power grids.
This is serious stuff. I had no idea.
Yeah, it's pretty important.
So CODEX's mission is about a lot more than just satisfying our curiosity.
It really is.
It's about understanding a fundamental part of our solar system and using that knowledge to safeguard our technology and our way of life here on Earth.
Well said.
This deep dive has been incredible. I feel like we've only scratched the surface, though.
We have, but there's just so much to talk about when it comes to the sun and the solar wind.
I know. It's such a fascinating and complex system, and I can't wait to see what new discoveries emerge from CODEX's observations. For our listeners out there, if this deep dive has sparked your curiosity, I encourage you to do some exploring of your own.
Yeah, there are tons of great resources available online.
You can learn more about the solar wind, coronal heating, space weather, all sorts of fascinating topics.
And who knows, maybe one of you listening will be the one to make the next big breakthrough in solar science.
That's right. Keep those questions coming and never stop exploring the wonders of the universe.
And until next time, keep looking up.
All right, so before we went to part 2, you're about to tell me something else cool about CODEX, something that I would find intriguing.
Right. Well, we're talking about all these mysteries surrounding the solar wind. Like, how can the corona be millions of degrees hotter than the sun's surface, even though it's further away?
Yeah, that's the one that really blows my mind. It's like finding a scorching hot oven mitt lying miles away from a fireplace. It just doesn't make sense.
Exactly. It completely defies logic. And to make it even more puzzling, The exact mechanism behind coronal heating is still a hot topic of debate among scientists.
A real scientific showdown. Okay, so remind me again, what are the leading theories in this cosmic heat battle?
Well, one theory is all about these things called nanoflares. They're like tiny solar flares constantly erupting all over the corona. Now, individually, they're pretty small, but if there are enough of them happening all the time, their combined energy could potentially explain those crazy high temperatures.
So it's like the corona is getting bombarded with microscopic heat bombs. That's a pretty intense image.
It is.
What about the other theory? How does that one explain the heat?
The other theory focuses on Alfvén waves.
Alfvén waves.
Think of them like ripples on a pond, but instead of water, it's magnetic energy traveling from the sun's interior out to the corona. These waves carry a lot of energy, and when they reach the corona, they deposit that energy, kind of like surfers crashing on a beach, which heats it up.
Okay, so we've got explosive nanoflares versus surfing waves of energy, both trying to explain how the corona gets so hot. But how can CODEX tell us which one is right?
Well, remember those blobs of plasma we were talking about earlier? The ones launched from the coronal loops?
Yeah, those are pretty cool.
CODEX can measure the temperature of those blobs with incredible accuracy, and that's going to be key.
Key to what?
To figuring out which heating mechanism is at play. It's all about looking for specific signs.
Okay, so what kind of signs would point toward nanoflares versus signs that would point toward Alfvén waves?
If CODEX detects sudden, localized spikes in temperature within those plasma blobs, that would support the nanoflare theory. Imagine those blobs getting hit by a series of tiny but powerful explosions, causing their temperature to jump up really quickly.
So it's like those blobs are carrying little thermometers and CODEX is checking for any sudden fever spikes.
Exactly. But if CODEX observes a more gradual, widespread increase in temperature, possibly with wave-like patterns, that would lend more support to the Alfvén wave theory.
So more like a slow and steady warming trend as those waves gently deposit their energy.
Precise.
This is incredible. Just by studying these tiny blobs of plasma, we could unlock a fundamental mystery about the sun.
It's pretty amazing, isn't it?
It really is. It just shows how interconnected everything is. What happens on the sun affects us here on Earth, and understanding those connections is so important for our future.
Absolutely.
Well, I have to say, this deep dive has been an absolute blast. We've explored the mysteries of the solar wind, from its origins in the sun's atmosphere to its potential impact on Earth. We've talked about coronal heating, space weather, and the incredible technology behind CODEX.
It's been a great journey.
It really has, and I know I've learned a ton, and I hope our listeners have too. So to everyone out there who tuned in, thank you for joining us on this deep dive into the fascinating world of the solar wind.
We hope you enjoyed it.
And remember, keep those questions coming and never stop exploring the wonders of the universe.
Until next time.